Hello, I wanted to make a video that will introduce you to our next lab, our next virtual lab. It's lab number 8. It's entitled Island Biogeography. And this lab will give you a chance to explore how changing environments, in this case, changing island environments, has the potential to impact species diversity, albeit in a virtual environment. So on Google Classroom, there is a link to the simulator. I would encourage you to take a look at the background information. It's not very long. That will introduce you to the simulator. You're welcome to use the tutorial to guide your work if you'd like, but it's not required. You're going to spend most of your time in the Run Experiments tab. So what I'm going to do is click on Run Experiments, then quickly press Pause, because I want to pause or freeze the simulation in this particular spot. I'm going to go ahead and click on the lower right-hand corner to the design of the experiment, but I'm really doing this just to show you first the default conditions, but also introduce you to some of the variables that you might be interested in testing as part of your own experiment. So you can alter the habitat of these islands, you can alter the island distance from the mainland, you can alter the island diameter, you can alter the migration rate, you can alter the mortality. I will say the taxon up here, arthropods, birds, reptiles, mammals, that's just going to highlight the different types of organisms, the different types of species that are either occupying the mainland initially or one or both of the islands later on in the experiment. Okay, but let's hold off on changing the variables right now. Let's go ahead and go back to the data and go ahead and run the simulation under the default conditions. The default setting is kind of slow, so you're welcome to speed it up. And what we're going to do here is try to freeze the simulation at intervals of 100, or as close to 100 as you can possibly get. All right? So the data that you're going to be collecting is right here. It's the current number of species on each island, as well as the average number of species over that time interval. In this case, 100 time units. I have shared a spreadsheet with you through Google Classroom. Everything you see here are my sample data. But on the left-hand side of the spreadsheet, this is where you're going to enter your default data. So again, intervals of 100, and you're going to be recording data at each of those intervals for the total number of species on each island, as well as the average number of species on each island. The rest of these parameters will probably stay the same initially because they all match the default conditions. Okay, so the goal is to collect data at intervals of 100 for a total time of 500 time units. All right, moving on. I'm going to go ahead and reset the entire simulator. And this time, I'm going to choose a variable to manipulate. In the sample spreadsheets that I created, on the first spreadsheet, I manipulated the island distance. I actually moved it as far away as I possibly could from the mainland. Hopefully you can see the island moving. For the sake of this example, I'm going to move that island back and manipulate the island diameter. This is the second spreadsheet sample that I created, and make it as small as I possibly can, 64 kilometers. All right. So all of the variables I'm going to keep the same. Go back to my data, press start. Feel free to speed it up. And again, at intervals of 100 or as close as you can, you're going to be recording the data. And again, the data, current number of species on each island, as well as the average number of species on each island during that time interval. Okay, those data are going to go on the right-hand side of the spreadsheet. Okay, in fact, I can show you. Here's the second sheet. So there's the island diameter that I changed. Notice it's different from the original default island diameter. All the other variables stay the same. And here are my data in the data table. Okay, intervals of 100 for a total time of 500 time units. All right, so I have all these data. How do I know whether or not changing this particular variable had a significant impact on the number of species that are occupying the island? Well, you can probably guess from the sheet down below, the title of the sheet down below, that we can do a chi-square analysis. Now, I will say up front that the null hypothesis that you pose, as well as the analysis that you perform, will be dependent upon the variable that you choose to manipulate. So again, I chose island size, And I can already tell that I'm going to need to edit my null hypothesis because I just copied and pasted it from the other spreadsheet. But that's going to be easy to do. In essence, what I'm going to have to do is revise it to account for the island size and not the island distance from the mainland. But I can tell you that all of the data here are coming from the previous sheet from data table number 2. The observed data, pretty straightforward. They're coming directly from that 500 time point, right? I want to know how this variable, island diameter, changed the species, the total number of species over the course of time, okay? So those are my observed values. My expected values, well, they're going to come from the control conditions. Same time point, remember the chi-square test is being used to analyze discrete data, but this time I want to know what the species diversity would have been had I never changed the island size, okay? So when I go back to the sheet, right, I'm comparing the two islands under the large island condition versus the small island condition, okay? So I go ahead and enter my values. In this case, the expected values, island 1 large is 9. And for island 1, right, it's also 9. If I go back, you can see that over here. Again, I'm using from my expected conditions, right, for my expected values under the default conditions. After 500 time units, I expect both island 1 and island 2 to have 9 total species. Okay? All right. Well, what you run into if you enter those values is that the observed total does not equal the expected total. So I have to manipulate my data a little bit to make those two sums equal to each other. But it's pretty easy to do. Down here, I've actually done that work for you. So I had an expected value of 9 here. There were 18 total observations that I made. So that fraction times 11, which is the sum of the number of observed values, observed species, okay? That formula will kind of transform the expected value in a way so that when I sum those two values together, now the number of observations for both of those two groups, the observed and expected groups, they equal each other. If I left the data as I did up here, I'd be comparing apples to kumquats. That's not going to work. Here, I'm comparing Macintosh apples to Granny Smith apples. All right? So I go ahead and do the chi-square analysis. I get my chi-square statistic, and I'm going to compare that to my critical value. Well, the way that I set up this analysis, I had two different groups, two different islands. So I've got two categories. That's a 1 degree of freedom. It's always safe to use my p-value of 0.05, that 5% chance, that 5% probability that the difference between the two groups is due to net chance, or in biology, natural variation, and not due to the fact that I actually changed the island size. And my critical value there is going to be 3.84. Well, 4.45 is greater than 3.84, so that's telling me that there is a significant difference between the observed and expected groups, which in a way makes sense, right? If I change the size of the island, I would expect there to be fewer species present because with less space, there's more competition for limited resources, and that area is going to be less able to support a higher species diversity than you might expect on a larger island. So even though I'm going to have to go back here and edit the hypothesis, my null hypothesis, to account for island size and not island distance, regardless, I'm going to be able to reject the null hypothesis as a result. All right. So chances are you'll need the most support around generating the expected values. That's pretty common. So don't hesitate to reach out if you need some help with that as you're manipulating your variable and collecting your data. But I do hope this video was helpful and will provide a good starting point for setting up and performing your virtual experiment this week.